Section 1.1, example 1.1, using sigma notation. So write in sigma notation and evaluate the sum of the terms, 3 to the power I for I equaling 1, 2, 3, 4, and 5. So let's start with that first one. Now what we're looking for is sigma notation. So with sigma notation, let me zoom in for you guys. We have sigma. This here is a Greek letter sigma, and at the bottom is where we start with. So we're letting I go from 1. And at the very top up here is where we're stopping. So notice over here that we're stopping at 5. So going from 1 to 5 and only integers. We have that. Now let's see what we were looking for. So 3 to the power I is what we're looking for. So we're just going to raise 3 to the power I. So that would be our sigma notation, but they also want us to solve it. So sigma notation and solve. So what this is telling us is to start where I is equal to 1 and go all the way up to where I is equal to 5 using just the integers. So 3 to the power 1 plus 3 to the power next number would be 2. And we keep going until we get to the final number. 3 to the power 4, and lastly 3 to the power 5. So now at this point we just have to evaluate. So I know some of these values off the top of my head. 3 to the power 1 is 3, plus 3 to the power 2, or 3 squared, that's 9. Then we have 27, 81, and off the top of my head I don't know exactly what this is. Let's get our calculator. So we're looking for 3 to the power 5. So 243. And adding all of those up together. So 3 plus 9 plus 27 plus 81 plus 243. That gives us 363. And there we go. So that's us evaluating that very last solution. Much better. Okay, so there's that part. And now looking at this last part here. So let's move this up. Write the sum in sigma notation. So here they're really not asking us to solve for it. They just want us to find the pattern and put it in sigma notation. So we have 1 plus we have 1 over 4, 1 over 9, 1 over 16, and 1 over 25. So with the exception of this one, all of these have a numerator of 1 up top. And what I notice about the denominators is they're all perfect squares. So let's try to write that as a perfect square. So 1 plus, we'll leave that one alone for right now. This looks like 1 over 2 squared, 1 over 3 squared, 1 over 4 squared, 1 over 5 squared. And now that I think about it, this one right here, we could rewrite as 1 over 1 squared. So I see that we have integers 1, 2, 3, 4, 5, all of those, but reciprocal and in order from 1 to 5. So what I'm thinking is we could actually just write it in that way. So sigma, again, we're starting at 1 and ending at 5. So we're going to let I equal 1. And we're going to let I go from 1 to 5. And here it looks like we have 1 over I. So 1 over 1, 1 over 2, 1 over 3. So the denominator is the one that's changing. There's only one thing left. I see that each of these have a square. So here we would have that square there. Just to make sure, let's kind of do a little bit of scratch work. So this would be equal to, the first one would be 1, so 1 over 1 squared. And the next integer would be 2, 1 over 2 squared, 1 over 3 squared. And we continue until we get to the very end, 1 over 5 squared. All right, it looks good to me. So there we go. That's our sigma notation for that scenario there. And that's it. If you happen to have any questions, please feel free to ask. Otherwise, bye.